Climate change is a global phenomenon that largely impacts urban life. Rising global temperatures causes sea levels to rise, increases the number of extreme weather events such as floods, droughts, and storms, and increases the spread of tropical diseases. All these have costly impacts on cities' basic services, infrastructure, housing, human livelihoods, and health. At the same time, cities are a key contributor to climate change, as urban activities are major sources of greenhouse gas emissions. Estimates suggest that cities are responsible for 75% of global CO2 emissions, with transport and buildings being among the largest contributors. As such, this online course, Urban Climate, funded under the Erasmus Plus project, Geo-information educational resources for climate change management, will focus on cities and urban environment. The first topic is about urban heat island. How do we derive land surface temperature from Landsat images? A three-part YouTube video from NASA training program is used as the base. This presentation is based on the online materials developed by NASA's Applied Remote Sensing Training Program, or ARSET. ARSET is a part of NASA's Applied Science Capacity Building Program. To learn more about it, please visit their website, appliedsciencesnasa.org, ARSET. The training has three parts. Here you can find the link to the YouTube channel. You are expected to go through all the three videos, especially Part 1, which provides the background on how to use satellite images to estimate surface temperatures, and which can be used to characterize urban heat island globally. Title of Part 1 is Land Surface Temperature-Based Urban Heat Island Mapping. It covers overview of ARSET, background on urban heat island, satellites and sensors for monitoring urban heat island, limitations of satellite data, demonstration of converting Landsat 4 to Landsat 8 thermal data to land surface temperature. Part 2 is integrating in situ observations with satellite imagery. It covers reviewed previous session and introduced guest speaker. Background with case studies integrating in situ observations with satellite imagery in select American cities. And the last, Part 3, is mitigating urban heat island via long-term urban climate monitoring. It describes NASA NOAA case study using Landsat thermal imagery to assess urban heat island in select American cities. Diurnal effects of urban heat islands using GOA's land surface temperature with land cover. Then a case study of urban heat island and land cover in Huntsville, Alabama. The learning objectives for these topics are the following. Summarize the characteristics, causes, and impacts of urban heat islands. Identify the satellites and sensors used in analyzing urban heat islands. Replicate the steps of converting data from the Landsat series of satellites using Google Earth Engine. Recognize the limitation of satellite data for urban heat island analysis. Computing land surface temperature, or LST, using thermal Landsat image in a practical. We will introduce the close relationship between urban climate and urban heat island. Then, starting from slide 10, are the information for practical 1, with which you will learn all the steps to generate a surface temperature map with Landsat thermal spectral image. In the figure, a dotted line shows the profile of temperature stretching from the rural to the densely developed central business center. The city center is characterized by high-rise buildings, and suburban areas are characterized by low-rise buildings, with less concentrated and more spread-out development. The temperature of the city center is significantly higher compared with its surroundings. So, what makes that difference? Firstly, it is related to building materials. Concrete of buildings and asphalt paved roads are heat absorbing. The built-up areas create impervious surface. These impervious surfaces have different radiative and thermal properties that generate higher temperatures. Within the city, temperatures varies depending on spatial distribution of water, soil, vegetated area, and impervious surfaces. There are many factors contributing to the urban heat island phenomenon. Firstly, urban geometry. Tall buildings are obstacles to wind flow, wind spring cooling effects. Secondly, weather. Calm and clear sky condition gives maximum solar energy, but strong winds and clouds covers will reduce solar energy received and hence suppress formation of heat island. Thirdly, geography. Water bodies moderate temperature. Lakes and sea in proximity will ease the conditions of urban heat island. Mountains can block wind and create different wind patterns. Consequently, relief area will affect the formation of urban heat islands. Fourthly, albedo and infrastructure. Building materials such as asphalt, concrete, and brick absorb and store heat, causing higher temperatures. Fifthly, amount of green areas and tree shades can provide natural cooling. Lastly, anthropogenic heat. Human activities involving industrial production, transportation that use fossil oil and gas, air conditioning in buildings, these all emit heat into the urban environment. The figures compare the thermal satellite image of the suburban area to the left and urban area to the right of Atlanta City. The red colors indicate high temperatures. The urban heat island can be visualized easily with satellite images. The heat island phenomenon has the following characteristics. It is most intense during midday with the sun, and it is typically strongest during height of summer season. The figure shows the heat island during the day at around 4 p.m. and during the night at 2 a.m. There are two types of heat island. One is surface heat island, and the other is an atmospheric heat island forming in the air. The dotted lines in the figure shows the urban heat island more prominent during nighttime. During the daytime, temperatures measured at the surface and at the air are much more different than during the nighttime. There are many negative consequences of urban heat island. For example, it increases energy costs as we need more air conditioning, higher air pollution, and more heat-related illness and deaths. Global warming and climate change could bring longer heat waves, which often impact more of our most vulnerable populations. However, there are ways to mitigate the urban heat island effects by urban planning. For example, plant more trees to produce natural shading, create green roofs to provide shade and remove heat from the air. Green roofs also reduce temperatures of the roof surface and surrounding air. Slides 10 to 21 are instructions for the practical. They describe the step to download Landsat data, how to calculate land surface temperature from Landsat data, what is temperature, the mathematical definition of temperature, what is remote sensing radiant temperature, background of thermal remote sensing, the calculation of top of atmosphere spectral radiance, and the calculation of brightness temperature using emissivity and land surface temperature.